Okay, this is going to be part 4 of the shell method. Now, if you haven't done it yet, definitely go back and watch the first 3 videos because they will explain where these formulas come from. Now, what we're going to look at is this. In the first 3, we took volumes of revolution around the major axis, either the x or the y-axis. On this video, what we're going to do is find a volume of revolution around an axis other than the x-axis or the y-axis, so some other vertical or horizontal line. Now, in this particular one, we're just going to look at vertical lines. So we'll use the second formula down here on the bottom. So if you go around the y-axis or a vertical axis, put everything in terms of x. So our starting point will be this formula right here, the radius times the height with everything with respect to x. So let's take a look at the problems. Okay, for the first problem, suppose we had this. Find the volume of revolution of the solid generated by the region bordered by, and you've got y is equal to x, that would be this straight line right here. And you've got y is equal to x squared, that'll be this curved section of a parabola right here. And then finally, I want to find this. I want to rotate it around the vertical line, x is equal to a -2. So I'll put this dotted line right here. So if I take this area and revolve it around x is equal to a -2, it'll wind up looking something like this. So it'll wind up being a kind of a bowl-looking thing that looks like that. Okay, so what I want to do is find the volume of these blue shaded areas if I roll them around the axis. Now to start with, we'll start with the same formula that we always have. So if going around the vertical axis, so the formula will look like this. 2 pi times the radius times the height times dx. Now, just like all the other problems that we worked on so far, your problem is going to be to find the radius and to find the height of a single shell. So just like we've done in the previous videos, the first thing to do is to sketch a single shell in here. So since this is going around a vertical axis, I'm going to put a vertical rectangle, and I'll just pick it anywhere in between the top and the bottom lines right here. So it would look something like this. If I started here, it would go down like this, over here, back up like this, and across like this. And I'll go ahead and shade that a little bit. So what this is one rectangle. Now if I take this rectangle and roll it around this axis, I'll wind up with another one that'll be about the same height over here, so we'll stick one over here. And again, this just has to be a rough estimate. It doesn't have to be anything really great, but the other edge of the shell will look something like this. So there's my 2 edges of the shell. Now just to make it look like a shell, and again, not a great work of art, but I'm just going to come in and put a little bit of an oval around, so this thing would look something like this. If I rolled it, I get a great big wide shell that looks something along this line. And again, not a great work of art, just get something in there. Now the bottom of the shell would look similar to it. It'll be something kind of like this. We'll go from here to here. So this is just one fairly rough shell sketched in here. Goes over something like that. Okay, so there I go. I've got one rough shell sketched in. Now the reason you're drawing this shell is because that's the only way you can figure out what the radius and what the height is. So let's draw what those two things look like. First of all, the radius is going to be this. It's going to be the distance from the axis that you're rotating it around to the edge of the shell. So in this case, the radius would look like this. It's going to go from here over to the edge of the shell right there. So starting with the axis you're rotating around, that right there is the radius. Now the height of the shell, you need the height. The height is going to be this distance from here to here. So that's going to be the height. So you got to find the radius and the height. Now the only way to get this really is to get it off your picture. So let's go up and take a look at a couple things here. Okay, now here are the things that you know. You need to know, what is this radius? Well, first of all, the distance from the origin to this edge of the shell, this distance from here to here is going to be x. It's just right along the x-axis. And finally, this distance from here to here is the distance 2. So if this is x and this is 2, then r, the radius, would be equal to x plus 2. Just add the two of them together. So the radius is going to be x plus 2. And you can go ahead and put that down here. So the radius will be x plus 2. Remember, you want to put it all in terms of x. Now you got to find the height over here. Well, what the height will be, let's kind of draw a picture of it first. It's going to be this height to the curve line, which I'll call y1. Then it's going to be this height to the straight line, which I'll call y2. So the height of the shell will be this tall height minus the small height. So it's going to be y2 minus y1. But remember, you've got to put the whole thing in terms of x. When you solve this, it has to be in terms of x. So what you have to do is change these from y into x's. Well, y2 is the distance to the straight line. That's this height right here. y2 would be equal to just x. So you can put an x in right there. y1, that's the height to the curve line. That would be y1, and it would be equal to x squared. So this is going to be minus x squared. So the height is going to be, if you change it into terms of x instead of terms of y, it would be this. So x minus x squared. So down here you can put an x minus an x squared. And really at this point, the hard part of the problem is over. The hard part is getting the radius and the height in terms of x. Now at that point, it just strictly becomes an integral, so let's run through the integral and see what that looks like. Oh, one more thing, we've got to get the limits first. Let's take a quick look at those. You're going to integrate this thing, and we'll put them over here in blue, I guess. You're going to integrate this thing, the width of this one section where the two lines come together. So this is going to be A, this is going to be B. Now remember, the thickness of this thing right here, this thickness is dx. It's the width of one part of the shell. So integrate it from 0 to 1. So with that in mind, let's go ahead and run through the integral now. Okay, so what you're going to have would be just, the volume would be equal to 2 pi times the integral, again, from x equals 0 to x equals 1, this distance across here, so from 0 to 1 of x plus 2 times x minus x squared dx. Okay, the next thing you've got to do is to FOIL this thing out. So again, using your FOIL technique, so you'll FOIL this. And when you do that, you would get this. It will turn into 2 pi times the integral from 0 to 1. Now, first of all, it's first, outer, inner, last. So the first ones will be x squared. Then the outer ones will be minus x cubed. And the inner ones will be plus 2x. And finally, the last one will be minus 2x squared dx. So FOIL it out. Okay, so that's going to turn into 2 pi times the integral from 0 to 1. Now I'm going to go ahead and put these in descending order. So first of all, I've got the minus x cubed. Now here's an x squared and a minus 2x squared, so that'll become a negative x squared when you add them together. Then finally, you've got a plus 2x. All this with respect to x. Now go ahead and find the antiderivative of that, which would give you 2 pi times, and this will turn into the negative of x to the 4th divided by 4 minus x cubed divided by 3 plus 2 times x squared divided by 2. All evaluated from 0 to 1. Now, of course, on this one, this 2 and this 2 will cancel out. So this one and this one cancel out and just leave you with an x squared. So now go ahead and plug in the numbers. So we'll have 2 pi, and when you plug in the 1, you would have negative 1/4 minus, plug the 1 into this, 1 cubed would be 1, it'll be 1/3. And finally, plug the 1 into this, 1 squared would just be 1. So this is going to be plus 1. Now, when you plug in the 0, they all go to 0, so you can just leave it like that. Now, at this point, it's just a matter of getting them all over a common denominator. So this is going to be 2 pi. Now, the common denominator here is going to be 12. So what I'll do is multiply this one by 3 over 3, multiply this one by 4 over 4, and multiply this one by 12 over 12. So what that will get me to would be, this will become negative 3/12. This will become minus 4/12. And then finally, plus 12/12. And if you added all that together, you would have 2 pi times, this would be negative 7 plus 12 would be 5/12. So times 5/12. And then the final answer, 2 will go in 12, leave you with 6. You'll wind up with 5 pi divided by 6 for a final volume. So this is going to be the final answer to the problem right here. So let's go back up to the top and kind of take a look at it from the beginning. Again, draw a picture of it and draw just in a black shell, just with a single black shell in there. And then remember, you need to find the radius. So what you have to find is the radius, and you've got to find the height. And the radius, again, that's the distance from the axis that you're going to rotating about to the edge of the shell. So draw your picture. This little section is x, this is 2, and you can get the radius. The height is the height of it here, which would be y2 minus y1, but you've got to change them from y, you've got to put the whole thing in terms of x. So get it all in terms of x, run through the integral, and you've got it. So what that is, that's finding the volume going around the line x is equal to a negative 2. Now in the next example, we'll take a look at exactly the same problem, but just to show you a little variation, we'll rotate it around the line x is equal to a positive 3. So let's take a look at what that problem looks like and how it changes things. Okay, now rather than going around x equals negative 2, this time we're going to go around the line x is equal to a positive 3. So we start with the same function that looks like this. Now this time, if you rotated it around the line x is equal to positive 3, it would look like this. So a little bit different shape. Looks like an upside down bowl. Now again, I'll start with the same formula. Since I'm going around the vertical axis, I'll put everything in terms of x. So the formula is going to be exactly the same formula we had last time. And I still need to find exactly what I did last time. I've got to find the radius, and I've got to find the height. Now again, to do this, it's important, take the time to draw a single shell in there. So this time, my single shell will look something like this. I'll come into about right here, and I'll draw one single vertical rectangle right here. So over here, and go up like this, and this. So I'll shade this in, and again, doesn't have to be anything great, but there is one vertical rectangle. Now what I'm going to do is go straight across to this side over here and draw another one at roughly the same height where I've got the edge of both sides. So it'll look something like this, over like this, and up like this. So what that is, that's a couple of shells. Now, again, very roughly, go ahead and draw the curve, an oval that goes along through there. And again, doesn't have to be great, but just get it in there. So this thing's going to look something like this. So a single shell will go from here all the way to here, and then it kind of curves back around like this. And then the bottom of it would look sort of like this. So it'll go from here to about here, and from here to here. Okay, so you've got a rough single shell in there that gives you an idea about what this thing's going to look like. Now, the reason you draw that is because you've got to change the radius and the height into some function of x, and that's the hard part of the problem sometimes. So again, let's take a look at what we've got this time. This time, now the radius is still, it's always the distance from the axis that you're going to rotate around to the edge of the shell. So in this case, the radius would be this length right here. So that length right there is going to be r. But the question now is, what is it? Now the height is going to still be exactly like it was in the last problem. The height of the thing is going to be the height of that shell right there. So you need the height and you need the radius. Now to get the radius, you actually have to look at your picture. Here are the things that you know. The distance from the origin to the edge of your shell, that distance right there, is x. So you're going to go from 0 to x. So the distance from here to here is x. Now what this next one is the distance from here all the way across to here is 3. So if this distance right here is x, and this distance right here is 3, then this remaining distance from here to here would be 3 minus x. So it's going to be 3 minus x, and that's going to be your radius. So again, the distance 3 minus the distance x will give you 3 minus x. So what that's going to give you down here, you now know that your radius for this particular problem is going to be 3 minus x. So again, you got to get it right off the picture. Now the height. Let's take a look at the height. The height is going to be this height right here, which is, we'll call it y1, and this height right here, which is going to be y2. So the height will just be the difference in those two, y2 minus y1. So the resulting height of that black thing is going to be just like it was in the last problem, y2 minus y1. So the long y height minus the short y height. Well, now the long y height, that's the straight line, that's going to be this one right here. So y2 would be equal to x. So this is going to be just like in the last problem, y2 is going to be x. Then you've got minus. Now y1, that's the distance to the curved line, that would be y1, and that's going to be this distance right here. So that's going to be x squared. So the height is going to be x minus x squared, and you can go ahead and write that in right here. So that's going to be x minus x squared. And once again, you have a different radius than you did in the last problem, but the height is going to be exactly the same. So now, once again, the hard part of the problem is basically done, but let's take a look at one more thing we need to put in here. I think I'll do it in green this time. We want to find the integral from what to what. Well, you're going to integrate this thing. This is your dx right here. So dx is the thickness of the shell. So you're going to integrate this from 0 to 1. So that is a and that is b. So you're going to integrate it from 0 to 1. So now with that in mind, let's just run through the integral to get the final answer. So at this point, it just turns into a basic calculus problem. So what you'll have would be something that looks like this. The volume would be equal to 2 pi, and you're going to integrate it again from 0 to 1. So from here to here, so from 0 to 1. And the radius is 3 minus x. The height of the thing is x minus x squared. And you're going to do it all with respect to x. Now again, just like the last problem, go ahead and you've got to FOIL this part. So we'll FOIL this out. And when you FOIL it, you'll get this. This will be 2 pi times the integral from 0 to 1. Now the first one would be 3x. Then the outer one would be minus 3x squared. The inner one would be minus x squared. And finally, the last one would be plus x cubed dx. So FOIL that thing out. Okay, now go ahead and find the, let's rearrange it first. So I'll make this be 2 pi, and this is going to be the integral from 0 to 1. And I'm going to put them in descending order. So I'll have an x cubed. And then I've got minus 3x squared minus x squared, which will give me minus 4x squared. And then I've got the plus 3x on the end. So it looks like that. Now find the antiderivative of all of those. So that's going to give me x to the 4th divided by 4 minus 4 times x cubed divided by 3. And finally, plus 3 times x squared divided by 2. And I'll evaluate that between 0 and 1. Okay, so what that's going to be would be 2 pi times, and I'll go ahead and plug in the 1. So this is going to be 1 to the 4th divided by 4 minus 4/3 times 1 cubed, and then finally plus 3/2 times 1 squared. Now then you'd also have minus 0, but since they're all 0, we won't put that one in here. So this will change into 2 pi, and this will be 1/4 minus 4/3 plus 3/2. So it looks like that. Again, you've got to get them all over a common denominator. So what the common denominator is going to be would be 12. So multiply each one by whatever it takes to get it up to a 12. So I'll multiply this one by 3/3. Multiply this one by 4/4. And multiply this one by 6/6. That'll get all of them up to a 12. Okay, so that gets me to 2 pi, and this will become 3/12 minus this would be 16/12, and then finally plus 6 times 3 would be 18/12. And what that's going to give you would be 2 pi times 18 and 3 would be 21 minus 16. This whole thing will simplify down to 5/12. And then when you divide by 2, you would get 5 pi divided by 6. And that's going to be the volume of rotating this around the line x equals 3. So again, back up the top, just take a quick look at it. Looks something like this. Okay, now again, you want to find the integral of the radius times the height. To find the radius, it's the distance from x equals 3 to the shell, so that's going to be r. Again, look at your picture. If this distance is 3, and this little black distance here is x, then the difference in these two, going from here to here, would be 3 minus x. So that gives you the radius. The height is just like it was before. It's the difference in that y height and that y height. So y2 minus y1. But remember, you've got to put both of them in terms of x. So change y2 in terms of x, change y1 in terms of x. That gets you the entire equation in terms of x. Then you can find the antiderivative and get the answer. But remember, draw a picture of it and draw one shell. Just roughly sketch one shell in there, and from that shell you can use your picture to figure out, change the radius and height into some function of x. So there's a couple of examples showing you revolution around an axis other than just the x-axis or the y-axis.